we are going to hear from Chang She, co-founder and CEO of LanceDB, presenting the new data lake format for multimodal AI. Please welcome Chang to the stage. Thank you. You have a mic.
Okay. All right. Hello, everyone. All right. Last talk of the day. I'm the only one standing between you and I guess dinner and maybe happy hour. So I'm really grateful that you actually choosing to spend time here. All right, so what are we going to talk about today? Before that, just a really quick self-introduction. My name is Chang She. I'm the CEO and co-founder of LanceDB. I've been building data tools for machine learning and data science for almost 2 decades. I was one of the original co-authors of the Pandas library. I spent years building recommender systems and machine learning infrastructure at a company called Tubi TV, the streaming service. And today I'm working on LanceDB to better enable teams building AI applications and models to work with their data. So the central question that we want to answer today and with LanceDB is this. Everyone is interested in AI, but everyone has the same access to the same recent models, to the same advanced techniques. So when you're building an AI feature for your company, we have to ask, what is the difference between your AI features and your competitors' AI features? So we think the answer is, well, it's the data. Specifically, it's your data. How you connect your enterprise data to your AI features and agents, that's the difference between a commodity and a differentiated AI product. So how do we think about data? How do we think about data infrastructure and working with data in this AI world? Well, let's take a trip down memory lane. So in 2001, there was a Gartner study that published the 3 V's of big data. So raise your hand if you remember what the three V's mean for big data. Okay, only a few of you, right? So you're all dating yourselves. You're old like me. And so what the 3 V's mean, it's 3 things. One, it's volume, or basically just the amount of data that we're dealing with. Number 2 is velocity, which is the speed at which this data is being generated. And then number 3 is variety, the kinds of data that we're dealing with. All 3 are different today because of AI. So number 1 is volume, right? AI data is just much bigger. If you take a look at TPCH benchmarks, tables that only have tabular data, well, they're pretty small. Each row is around 150 bytes. You add OpenAI's embeddings, an order of magnitude bigger immediately. If you start adding images and videos, well, you're getting up to 3, 4, 5, 6x, 6 orders of magnitude larger than typical tables from before. Velocity is also much higher, right? So because of AI, we're no longer generating that data based on human input, based on manual input. We're generating that data automatically via model at hundreds of tokens per second. So not only is the data bigger, but they're also being created much faster than before. And number 3 is variety. So when you're thinking about an AI application or an AI model, a lot of times they're multimodal. So it's not just about numbers and time series and dates and strings. It's also about prompts, long-form text, images, and videos, and of course, the embeddings themselves that you're all used to dealing with. So if you put all 3 of these together, what it means is that traditional data infrastructure today is just not a good fit for teams that are trying to build the next generation AI infrastructure or AI applications or models. If you're storing data, especially multimodal data, on a traditional data lake, typically what you would see is a very fragmented system where parts of your data are stored in one format for one particular use case in one particular system. And in order to create a holistic workflow or an application, you're spending a lot of time piecing all of those things together, keeping them in sync, and you're paying for extra infrastructure costs for multiple systems and copying data back and forth. But more than sort of the infrastructure cost, it's the human time that is being lost that's really valuable. So this is actually an age-old problem, right? So this is a tweet from more than a decade ago in traditional data science, that data scientists come in thinking they're going to be doing really cool experiments, working on features, working on the model, but no, most of their time is actually spent wrangling data. It's still true today with AI. So when you have to manage so many different systems, this can drastically reduce research productivity. And even though AI is increasingly replacing human labor, human time is still worth a lot more than CPU or GPU time. Or perhaps you can argue that because AI gives us so much more leverage, human time is worth even more. So can we do better, right? Is there a system where storing and working with AI data is much easier, it's less costly, and it can improve rather than hinder our productivity? So that's the central question that we set out at LanceDB to design Lance format, this new storage format, a new multimodal lakehouse for dealing with AI data. So instead of having this fragmented system where you're storing data in 3, 4, or 5 different places and single purpose systems to do tasks like search and processing the data and then analyzing the data and training the data, you have a single table, one place to put all of your AI data in a single table on object store, the ability to incrementally enrich your data with additional features, right, without copying that original data, and the ability to run multiple workloads with compute storage separation in the same system. And finally, it's open source and it's open architecture. So not only does it do a lot for you, it also plugs into the existing open source ecosystem. So you can use Spark and Ray and PyTorch to process and train on that data. So what you get is what we call the AI native multimodal lakehouse. Is at the core, it is Lance format, which is the multimodal lakehouse format that you can store text and video and audio and sensor data all in one place on the object store. And on top of that, you can run your search workloads, your analytics workloads, and of course your training and pre-processing workloads. So let's take a quick look at a case study on how one of our customers actually use the multimodal lakehouse. So Netflix just published a blog post recently on how they use Lance as the foundation to build what they call the media data lake. So for the creative side of Netflix, the data infrastructure needs are very different, right, from traditional data engineering or even recommender systems. What they've identified is, number one, all of that data is multimodal, right? Of course, you have video data, you have the audio tracks, you have the text subtitles, you might have text descriptions of the content, and then you have cover art and maybe frames that are extracted from the content. There's a lot of derived fields where you've extracted features from that data. So these contain embeddings for search, maybe closed captions, transcriptions from the audio, and then tags and other metadata information, right? All of that data is, number 3, unstructured and is massive in scale, especially when parsed out, right? So a single video can generate hundreds of gigabytes of data. And if you think about, the last time you binge watched on Netflix, how much content that they have, we're talking about many, many petabytes of data. And then lastly, sort of to step back from just the technology, it's very deeply intertwined with the creative workflows and the business and the asset lineage, right? So you have this set of assets that are continuously being collaborated upon with different teams, and that are continuously being enriched over time from team to team, from process to process. So the pain point and the challenge there is if you have traditional lakehouse infrastructure, what you're faced with is fragmentation. Each team might have to manage its own data infrastructure, its own copy of the data. Collaboration becomes difficult. The infrastructure cost is astronomical. So how do you create this unified whole? And then another challenge is the need for creating feature engineering pipelines, right? So to go from raw video assets to like a trained model for various purposes, there's a rich enrichment. There's a sort of sophisticated enrichment process. So some of the examples might include you're extracting, if you look on the left, you're extracting metadata by directly running things like FFmpeg on those video assets. You go through data curation, cleanup, and then embedding to generate searchable data sets. And then you're extracting features by running models like, I think you see like Lava or Llama Vision to create captions and generate descriptions out of images. And finally, you can load that training data into PyTorch and into the GPU to train a model to do various tasks, right? So if your data is all over the place and you have multiple systems, this becomes incredibly complicated and very difficult to do and requires a lot of human intervention. With LanceDB, it's not just about, with Lance format, it's not just about making those pipelines easy, but we solve the foundational problem, which is creating the single source of truth for their data. So in one table, they have, of course, just tabular data like before, but you have the actual assets. Then you're incrementally creating these features. Many of them are not known what's needed when you first ingest that data. So you're looking at things like you're running a model over the assets to generate safety scores. You're generating captions and then embedding those captions. And then you might also embed the images themselves. And all of these need a single place or belong in the same table. Right. Finally, we talk about collaboration. So the single source of truth, this single table, makes it a lot easier for all of these different personas and all of these different teams to work with each other because they have one thing that they're looking at, so that they're not worried about mistakes when copying data from one place to another. So to summarize kind of this case study, we can see how it highlights the difference between traditional data lakes and the media data lake, or this multimodal lakehouse that Lance enables. So the data types are different, the schema are different, the query workloads are also very different, and of course the users are even different in this aspect as well. So why does Lance, or how does Lance solve this problem? We do it by kind of rebuilding the foundation, right? Lance, as a format, it's a columnar format that targets AI workloads natively. So instead of as a sort of an afterthought, it's the only format that gives you all three of these abilities to do fast scans, so you can load data into PyTorch very quickly, to do random access very quickly, so that you can do search and you can do shuffles very quickly, and the ability to deal with large blobs, right? So no other format is effective at storing both your large assets like images and videos, and also your metadata, time series, and maybe even medium-sized data like embeddings. So on the retrieval side, right, so if you think about searches, you're searching through a data set and maybe you're finding the 10 rows that are closest to a search term. Well, those 10 rows are all over the place. So if you have a data format that doesn't give you random access, well, even if you have an index that can locate the rows, if you can't find them, if you can't retrieve them very quickly, that doesn't do you any good. So massive scale retrieval, fast retrieval, depends on random access. Lance format also, by being with the virtue of being on object store, it also drastically reduces the cost of retrieval for AI. So how many of you have used a vector database in the past, right? So if most of the vector databases that you encounter will store the vectors and the indices in memory. They will load the whole graph or the whole index into memory and then do the search in memory. Well, RAM is expensive. If you have like 1 million vectors with, let's OpenAI vectors, for example, that costs around $180 a month for 1 million vectors if you want to store that in RAM. With Lance format, that's stored on Object Store. And LanceDB that we build on top of that is optimized for accessing data quickly from Object Store. Well, Object Store is very cheap, right? So it's what, 2 cents per gigabyte per month for on S3. And so if you have 1 million vectors, roughly that comes out to something like 25 cents per month. And moreover, by storing all of that data on Object Store and building the systems on top of it, we deliver what we call compute storage separation. So one thing that's very different about AI workloads for retrieval versus recommender systems and personalization is that for AI retrieval, there's usually a much larger amount of data and vectors that you're searching through, but maybe a smaller amount and a elastic workload in terms of like queries per second when you're running that retrieval. What that means is traditional vector databases that doesn't give you compute storage separation, they will require you to either be wasting a lot of storage space or you're wasting a lot of CPU. And at the end of the day, it's very expensive and it's also very difficult to manage as you scale up and scale out. And so Lance gives that advantage to not only reduce the storage cost, but allow us to scale out much more efficiently than vector databases. The productivity gains from Lance format is also massive, right? By allowing you to store all of this data in one place for teams that need to build compelling AI, you need more than search, right? Whether you're building agents or you're training a model, you need to plug that data into PyTorch. You need to pre-process that data, right? You take a big chunk of text in. You need to split that up so that it fits within the context window. You need to create embeddings. You need to maybe generate tags. You need to clean that data. And after all of that, then it becomes searchable, right? So to do all of that in different systems and different copies of the data is very cumbersome. Well, Lance allows you to accumulate new features and new data as you go along, and it allows you to run search workloads, analytics workloads through SQL, and then also just keyword retrieval and hybrid retrieval all in the same table. And finally, with traditional data lakes, how many of you are familiar with like Parquet? Okay, so with Parquet, you can't really add a feature, or you can't really add a column without having to copy the overall data set. And even if you add columns with something like an Iceberg, it's not very careful after you add new rows, and you can't easily backfill tables, backfill columns after you've added, or backfill rows after you've added new columns. Well, Lance format actually creates this, what we call a two-dimensional data evolution, so that you can incrementally add both new columns and new rows without copying any of the original data, right? So when you're dealing with just tabular data, just numbers, making a copy of a column or partially of a column, it may not be that harmful. But if you're talking about a table that has petabytes of video data, you really don't want to do this over and over again as you enrich your data set. So for this purpose, Lance is designed so that we support what we call zero copy data evolution. So different columns and rows operations are added as separate files, and there's a metadata layer that kind of stitches them together. So top-level systems like the readers and Spark and Ray treats it as a single table. Okay, so with that, what we deliver with the multimodal lakehouse is the ability to really pre-process your data and do training very easily. So at some of our customers, we were able to take advantage of both the advantages of Lance format and the lakehouse that we built on top to reduce feature engineering time from weeks to hours, and have them do more and manage less, and give them high performance training at a fraction of the cost of existing systems. So LanceDB today is powering the future of multimodal AI. So we have partners that are large tech companies and data infrastructure providers that are using LanceDB, building on top of Lance format. A lot of frontier model companies are training their models. So next time you generate an image or you generate a video with some of these popular services, know that a lot of those models are being backed by Lance format and being trained on Lance format data. And of course, cutting edge agent companies are doing automation on data analytics, on legal and fintech, all on LanceDB for a variety of use cases. Lastly, I just want to point out, so if we look across the infrastructure landscape, if we zoom out a little bit from just Lance format, it's really, really interesting because AI, because it's really taken over the world by storm, it's creating a lot of new trends for the underlying tooling. So I've sort of noticed three really interesting trends in data infrastructure for the AI stack. Right, so how many of you have heard the term carcinization before? So just one of you. Okay, okay, yeah, of course. So carcinization is a term that was created in 1916 by an evolutionary biologist, and he looked throughout history of species, and what he noticed was that no less than 10 times throughout history, different crustaceans will independently evolve crab-like body plans. So he called this phenomenon carcinization. In plain English, everything becomes a crab, right? And so this is what the Rust community has used as the phenomenon to say a lot of database technology, data infrastructure projects are now being rewritten in Rust, instead of, say, the JVM or C++ or Python. And so interesting bit of trivia is that the biologist who discovered this term, his name is actually Lancelot. And I swear I did not know that was his name when I came up with the name for the project. Number two is, multimodal data is becoming a first-class citizen, right? So, we're all thinking about, like, when is AGI happening? When is AI going to be really human or even surpass humans? Well, humans have 5 senses, right? So AI has to be multimodal. So it's no longer optional. So we're moving data infrastructure from this like TPCH focused world to focusing on search and training and handling multimodal data. And then number 3 is it's not just about, if you're a tool maker, if you're an infrastructure maker, it's not just about developer experience anymore, but it's also about AI experience or agentic experience. It's about how do you create your tool to be consumed by the model, to be consumed by agents, to be consumed by MCP servers and coding agents and LLMs that can recommend tools to users, right? So it's about a focus on changing the types of documentation you write, really focusing on clear and self-contained examples, and then integrations into stuff like MCP servers and other sort of AI SEO kind of tooling. All right. So those are, if you're creating infrastructure today or creating new data tools today, I think those are 3 really interesting trends that is worth paying attention to. Cool. So thank you very much for attending my talk. I put a QR code for you to get in touch with us if you're interested in Lance format or LanceDB. And yeah, really appreciate you coming to the talk. Open for questions.